From our days as hunter-gatherers to the time of Alexander the Great to, well, now, humanity has looked up to the sky and wondered if anybody's been looking back. But now, for the first time in human history, we might stand a chance of answering that question in a reasonable amount of time. So in this video, I'll investigate 3 ways we might find alien life this century, or the next, going from reasonable and feasible to less reasonable and less feasible. Number 1. Looking out. It might just be that finding aliens isn't quite as exciting as in all the comics, blockbuster films, and old folktale myths. It might just be as simple as pointing a camera at a star. Granted, it's got to be a big camera and you need a bit of software, but here's the breakdown. When light from a planet passing in front of a star reaches a microscope, it gets split up into its corresponding wavelength. You know, the RGB bar we're used to seeing on Canva or Photoshop. Anyway, depending on the amounts of, say, blue compared to red compared to orange, we can tell what chemicals are in the atmosphere of that distant planet. This works because as the light from a star is coming our way, the gases in the planet's atmosphere mess with the waves, shortening them, making them bounce around, etc. We can use AI, or good old human thinking, to identify the interference we detect and find the makeup of the planet's atmosphere. Okay, science done, aliens are up. This data can be collected in a few ways, but in order to really try to figure out which method is the best, let's pretend we're an alien looking at Earth, trying to figure out if there could be some extraterrestrials living there. So, the first thing to do would be to take an initial check up of our atmosphere. And it would obviously vary slightly depending on proximity and technology of these aliens, but they would probably approximate the atmosphere to be the numbers you see on your screen. From this, these aliens would figure out we have the chemical recipe for life, carbon and oxygen, as well as incubators for life, our oceans. Okay, so now these aliens have to run measurements over a long period of time. Because you know what one of the best indicators of smart species are? Messing up your home planet. That's right, if these aliens had been measuring us for 23 years, they would have noticed an 11% increase in the amount of carbon dioxide in our atmosphere, and a 47% increase if they had been sticking around since the first steam engine. All of this is again assuming they're good enough to notice increases in tens of parts per million of a gas. A relatively difficult task, should you try attempt it. Number 2. Calling out. This one is kind of subject to discussion because instead of us, humans, being the observers, we kind of just shout out, hoping somebody will detect us. See, radio waves got the speed of light, and humans for the last 80 years have been quite noisy with these little gadgets. This means human messages have already travelled 80 light years. Well, it's like nothing compared to the galaxy, it's the best we got. Fun fact, although the message would be really distorted by now, the first radio waves that would reach aliens would be the broadcast of the 1936 Olympic Games in Berlin. Using radio is also one of the methods that the Search for Extraterrestrial Life, or SETI, is employing in order to both listen and project humanity's radio waves. Now, this SETI Institute does a lot of stuff to find extraterrestrials, more than I could go over in a video, but I'll mention some of them now. SETI is in a partnership with NASA and a few other agencies that allows them to hunt for Earth-like planets. They've also started coordinating more efforts to search for, quote, extrasolar laser flashes. This is fancy science language for flashing lights that don't come from a star. Anyway, on top of this, the SETI Institute maintains its place as a leader in astrobiology research. This is the study of life in alien environments. In order to do this, they get on expeditions to extreme places on Earth, like the Arctic and large salt flats. Alright, sci-fi fans, you're gonna like this. We know that it's near impossible for any undetected intelligent life in our solar system to exist today. And so if we want to go send something man-made to a potential candidate for alien life, we're gonna need to go to a different system. That's a lot easier said than done. However, it's not completely out of the realm of possibility that somebody born today sees the first interstellar ship, although ship is a bit generous for what we're trying to achieve here. The most feasible possibility for us creating something that goes interstellar in this century is a combination of the Bussard ramjet design and a laser-powered rocket. So let's take a deep dive into how these things are going to work. Alright, so let's take a look at the design of the first component of our craft, the Bussard ramjet, a proposed but scientifically proven method of accelerating a spacecraft to large speeds over time. This design takes advantage of the fact that even in a vacuum as empty as interplanetary and interstellar space, forces that lead to momentum can still be extracted. This comes in the form of a ship, no larger than somebody's fist, but with an interstellar sail that spans many, many football fields. This sail, instead of relying on wind like the old boats on Earth, they rely on the forces of light. more specifically photons originating from a star like our sun that hit this large reflective surface and propel the ship forward ever so slightly. An example of this would be the Planetary Society's Light Sail 2 mission, which, under funding from the Society's members, was a test flight that verified the use of a solar sail to adjust the craft's position in space and change Light Sail 2's orbit. Okay, so armed with this knowledge, we could just send out a really small craft with a real large sail and a bit of initial velocity and call it a day, or century. But there's one problem with this. Photons are really tiny. So tiny that they actually don't weigh anything, and therefore rely on their wavelength to determine the amount of momentum they transfer to the sail. And so we need a lot of photons over a lot amount of time to get this craft to a meaningful velocity in the length of interstellar travel. This entire process would take time on a scale of centuries to happen, and that's boring, because we won't be alive to see that. Instead, we need a way to leverage this passive thrust as well within initial and compounding levels of velocity, so maybe, just maybe, we'll be able to reach the nearest star. By the way, the closest one to us, Alpha Centauri, is about 4 light years away, and so we'll be basing the time approximations off that. Now, it's time to visit the second part of this ship. Trust me, we'll get to aliens in a sec. Remember the laser-powered rocket part of it? This is pretty much what it sounds like, but the plan in order to achieve this idea is quite extensive. First, a relay of laser-emitting devices will be constructed, either in orbit or on Earth. Here's less effective but less expensive, and space is more effective and more expensive. Then, a fleet of these solar sail crafts will be constructed and launched into space. It's better to have a fleet of them because of redundancy and getting more data of the system that we choose to point them at. Now, this laser-emitting fleet of satellites will blast the spacecraft with millions and billions of photons, causing a large amount of acceleration. Pair this with each craft having a stage utilizing conventional or ion methods of thrust before splitting off and letting the lasers do the work, and you have yourself a very fast vehicle. But wait, there's more. Putting a small compartment of hydrogen before your ship and directing the lasers at that could turn it into plasma and turn it into a tiny, lightweight rocket thruster. Okay, I know what you're thinking. This is cool and all, but I clicked on this video to find aliens, or at least find out how. And so here's how we can utilize this tech to take us to alien worlds. Right, so assuming a velocity averaging 10% the speed of light, which is achievable considering we use the top technology mentioned in this video, we'll get to Alpha Centauri in 42 years. And if we take 30 years to set it up, we're looking at an achievable amount of time to visit an alien world. Of course, there's probably no life in that system, but imagine we take thousands of these little craft out in all different directions, each targeted for a star that might take them 100 years to get to. On a galactic timescale, that's nothing. Plus, imagine that first photograph from another system, where you can see rivers and mountains and valleys on planets bathed in a different star's light. This is the dream of reaching out.